Hello everyone. The topic that we're going to talk about today is Azure Cloud migration. Basically, if you've got on-prem analytics, relational database workloads mainly, and if you want to move those into the cloud, talking more in detail about that. My name is Ali Rizwan. I'm the CEO of Seha Consulting, and I've got Ram Babu with me. He is another Microsoft expert, helping clients kind of move their environments from on-prem to the cloud, and advising clients on architecture of a move to the cloud as well. We'll get started. As an introduction, there's essentially two separate topics we're going to talk about: the typical analytics workload, what that entails, and then a more detailed dive is going to be on the topic on the right, which are components to evaluate the move to the cloud. That includes both cost as well as specific Microsoft offerings that are available. So starting with the typical analytics workload, what does that look like? So a modern data warehouse has evolved quite a bit. You've got, big data loads, you've got AI, ML workloads, you've got, obviously OLAP cubes, which are kind of still legacy type of workloads, data visualization, you've got your ETL packages as well, kind of data movement, data integration. This talk mainly focuses on the move of relational database management system workloads that you might run in the cloud. So a typical environment might be you've got various sources, coming from different OLTP systems that you're bringing into this red box here, where you might have like a staging area, you might have transactional replication happening from your OLTP systems into your data warehouse for operational reporting. You might have some other staging you might do, and eventually the data lands up into a star schema database. That's going to be kind of our baseline scenario, the workloads that happen on these relational databases for reporting, and what that looks like moving them into the cloud. So the evaluation component. So first, we're going to talk about why do you move something into the cloud, and what will it cost, what that cost look like. Then we're going to get more in detail into the benchmarks to calculate a total cost of ownership. That's important because when you're comparing your on-prem into the cloud, there's slight nuances and slight differences in how costs are captured. So being able to translate that becomes important. And then we're going to talk about when and what to move to the cloud. So specifically, what type of questions you should ask about your existing environment, and the reason behind kind of what problems you're trying to solve, and how to do kind of a pre-check before you decide to move those workloads into the cloud. Lastly, we're going to spend a good portion of the presentation on the cloud offerings that exist in Azure as of right now, and what a good fit for your organization and your workloads might be. So there's 4 separate offerings that we're going to talk about: just moving a SQL server onto an Azure VM, SQL server, Azure Sql managed instances, Azure Sql Database, and Azure Synapse dedicated pools. So why move, and what will it cost? So the why portion of it, it's really about flexibility. You can have different scenarios. So scenario 1, as I mentioned here, is low demand compared to what you expected. For example, for your solution or your application, let's say you have hypothetically 4 servers, but you end up only needing 2 servers for your solution. The flexibility that the cloud gives you, at least the cost savings with minimal friction, being able to downgrade that workload based on your actual need. That downgrade, the cost saving associated with that, and that flexibility is available with the cloud, which you may not have in the sunk cost that you may invest in the capital expenditure for an on-prem solution. Conversely, if you look at the other side in scenario 2, you may have high demand For example, you have an application, you got 2 servers, but you needed 4. The flexibility there is the queue times and the performance hit and scaling that the performance hit that you'll get with a solution that is running on max CPU and your specs, being able to scale that easily, smoothly, the options that cloud gives you with minimal friction with procurement and getting the hardware and the software, going through the process of setting that up. That's a lot easier with obviously moving into the cloud. Now, the cost piece of it, it's really, even though that flexibility is there, you have to understand what your specific workloads are and how those, what that cost is going to be. So for that purpose, you have to do a total cost of ownership. So yes, you've got the flexibility, the low demand and the high demand, but for your own workloads, you have to do a comparison from an on-prem solution that you're running right now and what that might look into the cloud, in the cloud. So you have to look at your own specific workloads and see what type of specs you're running and what that cost, what a comparable system or solution in the cloud is going to look like. Now, the cloud has, basically any system, both on-prem and the cloud systems, you've got some upfront cost and you've got ongoing cost. And part of this discussion focuses on, what are those upfront costs and where the differences lie and where are the costs heavy upfront, and comparing, cloud to on-prem versus the ongoing cost cloud to on-prem. So you have an apples to apples comparison, between the two costs. So when we talk about benchmarks, if you're going to your organization and you want to figure out, go talking to the right people and figure out do a total cost of ownership to do a comparison for your on-prem solution to a solution in the cloud, there's certain things you have to start off with, right? Like you have to see your existing solution, what are the total cost of ownership or that, right? So that's going to be your benchmark for your on-prem solution that you'll have then as like a baseline to compare against your solution in the cloud. So as I mentioned in the previous slide, you've got your upfront cost and your ongoing cost. So upfront cost in an on-prem, obviously you've got your hardware, you got your software. If you've got offsite disaster recovery, that can be a very expensive upfront cost of setting up a data center. In case of a flood in your specific geographical location, a lot of organizations have offsite data centers against such events. That can be very expensive. The labor costs for environment planning and procurement for an on-prem solution are another set of upfront costs. The ongoing costs, and those upfront costs, specifically hardware, software, offsite disaster recovery, they tend to be a lot more kind of on the heavier side. When you have ongoing cost, you do have certain ongoing costs even for on-prem, such as labor for maintenance, testing your ongoing data center costs around kind of cooling, insurance, fire protection. If you've got like certain type of sprinklers you need, or you might have other licensing fees that you incur on a monthly basis for your kind of backup and recovery, software and tools you might be using, or other tools you might be using from an ongoing perspective. Generally speaking, in a cloud sense, the ongoing tends to be more on the heavy. These tend to be light, but there are costs both in on-prem and in cloud solutions from an ongoing perspective. These are the most common solutions you'll have in an on-prem solution from an ongoing perspective. Then once you get these costs, so you have to figure out a depreciation timeline. So what that means is if you have a solution, right? Let's say you purchase a solution on-prem. You've got generally 3 to 5 years is the timeline for that specific solution. These costs that you calculate, the upfront costs and the ongoing costs, you have to spread them out over the lifetime of the solution that you're going to have that apples to apples comparison, because the costs in the cloud generally happen to be over a timeline. So like cost per hour, month, year. that, typically when Azure gives you an offering, they break down cost in that manner. So having the upfront cost and the ongoing cost, then the next step is figuring out a depreciation timeline, and spreading those costs out to do a total cost of ownership. And this is highly dependent on kind of how your kind of finance team captures this information, but it's a very important step when you're trying to make a business case for a move to the cloud, because these are the kind of the hard dollars and cents that you're gonna have to look at to see, okay, for a solution that I have right now, what is it costing me? If I'm to move to the cloud, what am I kind of leaving behind on the table? What are the on-prem costs that I'm going to have a baseline to compare with? And for that purpose, we offer templates to calculate those on-prem benchmarks, and those the goal really of the templates that we offer and is to be able to give you kind of just like an Excel template where you have all the costs, for your on-prem solution, that you can just take those kind of like a checklist one by one, be able to get from your business for your on-prem solution, and be able to have like that baseline, right? So it's designed to be a place where you start to capture your costs for your on-prem system. For now, the benchmarks on the cloud. So as you mentioned, we talked a little bit in the previous slide as well, but you've got the upfront costs and ongoing costs look a little bit different for your cloud offerings. You still have labor for, in the upfront cost, you have labor for environment planning and migration. That tends to be a lot more higher, because if you're an organization that's moving to the cloud, that planning and migration that you're gonna have to do upfront, it's gonna be a lot more intensive, because chances are your organization might be new to the frameworks in the cloud, and there's going to be kind of more planning effort involved. If you're using some services, and we'll talk about the different types of options you have, you may have more development, integration, and testing effort involved in your migration. So in addition to planning the actual migration itself, that's an additional cost that you'll have to incur, and they can be from low to very high, depending on the type of workloads you're running right now, and replicating those in the cloud. And we'll talk about this in more detail. And then obviously there's a change management and training piece, which if your organization's running on-prem solutions, moving those out to the cloud will have a certain cost there. Obviously the ongoing costs, the software and hardware that were there for on-prem, you're going to have a lot more. Things like bandwidth, which are definitely a new thing when you're talking about the cloud, both inbound and outbound bandwidth, which when we talk about bandwidth, we're really talking about the number of bytes over a period of time. So think about if you have an nightly ETL load, if you're running it on-prem, it's in the same data center, it's going from one computer to another, one server to another. Now, if you move that to the cloud, that bandwidth of moving that data from your on-prem system and doing extract and load into the cloud, there's going to be a bandwidth cost associated with that you have to take into account. And so, that's another kind of factor to take into account. And, we talked about labor for administration. Certain labor costs that you may have in the on-prem go away. For example, kind of your data centers, you may not have a lot of patching and updating to do for your data centers, but there's still other types of costs that are still there for labor for administration of your solution, but they're significantly less depending on the option you choose. And the challenge is really comparing the workloads that you have, on-prem with what the options that are there in the cloud, since there's quite a few options that are there. From a benchmark perspective, you also have other types of benchmarks and kind of questions you ask yourself when you're moving into the cloud on the type of workloads you have and the system performance. Like, is your system built for doing more reads, or is it also doing a lot of writes? What are the storage you're looking at? What are the compute options? And try to get at something with a time per workload. The type of workloads you have, if you're running it right now in your on-prem solution, what is that going to look like in the cloud? Is your customer going to notice any gains and benefit in the time for your current ETL load that you have, or kind of query performance timings that you have for your reporting solutions? Is that going to improve over time? And this is the control over features and resources that you have on-prem. This is a little bit more of a, it's more of a subjective, where obviously if you have a data center on-prem, you have control pretty much over every facet of your solution. As you move things to the cloud, by design, you're letting go of certain things. How important is that control to you? Similarly, for control, it's also in terms of features as well. As we talk about certain offerings in the cloud, not all the features that you have on-prem you might get in the cloud. So what is the value of those features? What is the value of that control that you have currently on-prem versus the cloud? And obviously, we talked about kind of data centers and availability. Having like what are the downtimes you guys have right now in your existing solution for kind of server maintenance and patching, and comparing that to what you will gain in the cloud with Azure. And this department, kind of availability, that's something cloud and Azure offerings are kind of very have quite a lot of benefit compared to the cost that you incur in this section, and the availability section. So when we talk about mapping your existing workloads to things that exist in the cloud, and we talk about kind of doing that mapping, we offer some templates for this purpose to help the organization kind of take those components and map to key elements in this in the cloud. And we also have kind of templates to help you do more like a what if scenario. Because moving to the cloud, Microsoft gives you some offers and benefits, such as you might attain some benefits with your existing SQL Server licenses. You might be able to reuse those moving into the cloud. You have a program called Azure Hybrid Benefit for Azure SQL Managed Instance. There's also another program around kind of bring your own license, where if you're running some solutions in your Azure environment, in your on-prem environment, you are able to take some of those licenses and apply them into the offerings you get into the cloud. And also the what if scenarios you go into, things you might costs you might incur that you may not have expected. For example, if you're running a SQL Server on-prem right now, you're going to have a lot of the software and hardware are probably going to be, if you have SQL Server Enterprise license, all the software costs are going to be part of that server that you're running. And a lot of folks, they run the relational database servers, they run the SSIS server, they may have OLAP cubes, all running on that one kind of beefy server with your the SQL Server Enterprise that gives you all those options. Now, moving those to the cloud, depending on the option you have, you may have to split those services out. So SSIS, if you go into like a managed instance of a database, SSIS is another thing you have to incur, because you won't get that with the offerings of SQL Server Managed Instance, for example. So some of those costs, depending on your architecture that you might incur, the template that we offer kind of helps you walk through those. Obviously, another thing to kind of keep in mind as you're moving things into the cloud, it's really a different paradigm when you're writing queries. If your queries, and many of us have been in the data warehousing environment, a rogue query is slowing everything down, it's causing table locks, and it has a performance impact as far as getting an ETL job to finish and getting the reports out to your user. The bad queries just kind of delay the time to insight, but they're not really increasing the cost, because your on-prem system kind of is what it is. The costs already sunk, and a rogue query that's taken a long time, the only really cost is the insight delay or the time to get reports out to your user. It's very different for rogue queries as they work in the cloud. You have the option to set like cost controls in the cloud for your queries, but bad queries lead to a lot more costs since we're paying for compute, as a separate, like for the amount we use. In certain cases, you have the options for reserving compute, but in some options where you're, for example, in serverless, you really pay for the compute that you're using. So the more compute you use, the more cost you have. Or let's say you picked a server size based on the query runtimes that you have right now. And if you were to tune those queries, you can maybe come down to a lower server size with lower specs and a lower cost. So that tuning and the impact of that tuning and how that impacts cost is much more direct with as you move things into the cloud. So that's definitely something. The rogue queries and being able to manage those and control those and the resource hit that they incur is definitely something different to take a look at. And it's part of the training effort that goes into kind of getting your resources ready for that move. And what and when do you move to the cloud? So what we're talking about here is, how old is your infrastructure? As we mentioned earlier, as you move things into the cloud, it really depends what you're trying to solve ultimately. But if you're in the year one of your solution, you're probably not ready to move that over. Versus if you're in year 5 of your solution, chances are that solution, you're going to have some migration costs to move to a new solution anyway. So if your current solution is that of end of life cycle, chances are you're going to have some costs incurred in that scenario. So depending on where you are, it certainly makes an impact of on the total cost of ownership and making a final decision of when in fact to move to the cloud. Also, depending on the problems you're trying to solve with your on-prem solution and trying to gain the benefits and leverage the benefits that the cloud gives you, have you done everything to maximize your existing infrastructure? That's something when you're looking for a move into the cloud. Have you tuned your queries? Have you kind of taken advantage of the options that exist to maximize your existing infrastructure, like partitioning, and kind of other tuning options that are there? Those are things you should look at and answer before you kind of decide on a move to the cloud. So next we get to the different Azure offerings. So as we mentioned, we're going to talk about 4 different options that exist. One is SQL Server Windows on Azure virtual machines. Then you have 2 very similar options in Azure SQL Managed Instance and Azure SQL Databases. We'll talk about where they're similar and where there's kind of important differences. And the last one is Azure Synapse dedicated pools, dedicated SQL pools, which is kind of a new kind of rebranding of the offering with Azure SQL Data Warehouse that Microsoft has rebranded to Azure Synapse as dedicated SQL pools. And in what scenario, based on the analytic workloads you have, which option to choose, which option would work best for the analytic scenarios on a typical kind of relational database management system. So with SQL Server on Windows, Azure virtual machines. So these are pretty much, you take your existing solution and you kind of, whatever kind of, you might be running virtual servers on-prem, you pretty much take that load and you kind of shift it into the cloud. So I've got so in this environment here, we have multiple sources that the organization might have, source A, source B, source C. They might be, so this green box here is your kind of your data warehouse server. You might have a staging area, you might have a data mart with your kind of traditional OLAP. You might have a kind of a replicated database from a transactional system, and you've got your SSRS, SSIS, SSAS, and you got your SQL agent running here. What SQL Server on Windows Azure Virtual Machine is just kind of as closest thing to a lift and shift as you have. You've got different machine sizes in the cloud that you can pick from, and you can kind of, depending on the specs you're running, you can find the closest one to that in the cloud. And it's definitely the lowest migration effort. And as we were talking about earlier, you have different options to pay for it. You can do a pay as you go model, or if you have existing licenses that you carry, there's a program, bring your own license, BYOL, that Microsoft calls it, that depending on the licenses you have, you can leverage those license investments that you already made for the cloud. Then you're really paying for just the infrastructure. And if you're running stuff in your data center right now, and you want to just reduce the cost of, obviously depends what other things you have running in the data center, but presumably if you just have this data warehouse running in your data center and you want to move that, you've got some benefits there of reducing overhead of maintenance of those data centers by moving that into in the cloud in a Microsoft data center. So this slide talks about the pay-as-you-go SQL. There's different images, as we mentioned, that you can select from, and there's different versions of those images that you have that we've kind of outlined here for SQL Server 2019, 2017, 2016, 14, 12, going all the way back to 2008 R2. So we were talking about the pay-as-you-go model. These are the images that you have that you can select from when you're trying to move into the cloud with SQL Server and Azure VM image, Azure VM image options. So depending on what you have, you've got the different licensing options, the enterprise standard, web developer, that you can kind of move those on-prem workloads into the image sizes that you have that are listed up here for the cloud. For bring your own license, these are the image, the SQL Server on Azure VM images. As you can see, some of them are not supported. You've got the 2008 R2 is not in there. But as you mentioned, if you've got certain, if you got the BYOL, if you want to leverage the BYOL, bring your own license option, you can do that with these image options that exist in the cloud. So what are the benefits of this option? Where, as we talked about, you take your existing server and you just kind of do, straight shoot, lift and shift into the cloud. Obviously, the benefit you're going to get is the scalability and flexibility, because you can move in between. You have the option to pick the different kind of versions, and as we talked about the cost savings for the server room overhead that you might have. If you've got kind of data center that you're running right now, that savings you're going to get by moving into the cloud. And obviously, if you need to shift the size of a VM, the time and labor to kind of procure software and hardware, with having SQL Server in the VM, it's a lot more kind of timely and less labor incentive from a scalability and flexibility perspective. Another benefit, if you're moving from on-prem, you have high level of control because the features are pretty much exactly the same now. All you do is kind of move it to the cloud. Whatever features you've got on your Azure, in the Azure environment on a VM, are pretty much going to be the features you have on-prem. We talked about high availability earlier as well. The options to do high availability have like kind of from a backup and restore perspective, it's a lot more cost effective with what Microsoft offers you versus replicating that on your own by having data centers in different geographies. Doing it on your own obviously is a lot more expensive than what Microsoft can give you. And the costs are generally comparable. And like I said, if anything, it might be less than what you're running right now because of the incentives Microsoft gives you. And it's an eventual stepping stone into broader adoption. And this has the lowest migration cost. If you're trying to move from an on-prem into the cloud, just moving a VM, it's going to have the lowest migrations cost. So if you're running towards the end of your existing solutions life of your existing solution, if you're going to move it to a new server or new hardware anywhere on-prem, that might be the best time to move this one into the cloud. You're going to have cost to move that into another on-prem set of servers anyway. You can kind of pack those into those migration costs you're going to have anyway and move those into the cloud to take advantage of all these other benefits that you get with that move. That specific benefit that you get with that move, the only real migration cost by moving to the cloud, there's going to be some kind of interoperability, because obviously you are moving it to another, some networking, interoperability issues you might encounter, not issues, but like kind of migration effort you might have. But as far as the workloads that you're running on-prem, they're going to have the least kind of impact. Whatever ETL jobs you've got running right now, whatever packages or stored procedures or scripts you're running, they're going to run pretty much the same in the cloud via SQL Server, Azure on-prem. Drawbacks, obviously, depends on what features and specs you're looking for and kind of what's important to you. You have a lot of the same labor costs towards maintenance of the servers, as far as taking your SQL Server and kind of managing that VM. We talked about the data centers, obviously moving that there, but as far as the VM itself, depending on the option you choose, you're going to have a lot, kind of the onus is going to be on you to manage it. And compared to the scaling options, compared to other offerings that Azure has, which we'll talk about a little bit later, and other options, you're limited there. So, and we'll talk about those, in future slide of what options that exist with with Azure SQL Managed Instances, and specifically around kind of the separation of storage and compute that are available in other Microsoft Azure kind of database offerings, which you're scaling into like one node in this option. So the next two offerings we're going to talk about, actually, let me kind of get back here. We're going to talk about these two offerings: Azure SQL Database and Azure SQL Managed Instance. We covered SQL Server on Windows, Azure Virtual Machine. We're going to talk about these two. For these two, there's certain concepts that are important around how Microsoft kind of sells the service. Okay, so the next couple of slides are going to be focused on that. So that the way Microsoft sells, there's something called a vCore purchasing model. There's actually different models we're going to talk about, but one of them is a vCore purchasing model, and that's applicable for Azure SQL Database, and it's applicable for Azure SQL Managed Instance. And we'll talk about those a little bit because they're important in when you're trying to compare your existing environments that you have on-prem to a managed instance in the cloud. Or Azure SQL Database in the cloud. So a vCore model, what that basically means is when you're purchasing, when you're purchasing kind of compute, storage, RAM and IO from Microsoft for running your databases in the cloud, you have this vCore purchasing model, and it gives you a lot more control in the way you pick your compute and storage. Okay, when you think about it, just to simplify it, it's when you're running a database, the compute and storage that goes with it, you have options to pick. Hey, do I want more compute and maybe like a little less storage, or maybe I want kind of low compute and kind of medium storage, or I want kind of high compute and relatively high storage, or kind of really high storage but kind of medium level compute. Those options are there with the vCore purchasing model, and that's really it's a good thing when you're trying to move from on-prem into the cloud, because that, depending on what your environment is, in your existing on-prem solution, the vCore model gives you a lot more transparency there, right? So as you're trying to pick certain, depending on, let's say you're running a 500 GB of RAM on your kind of current server, and you got a kind of Intel Xeon Gold kind of 5217 model at you're running 24 cores at a specific gigahertz speed. You get, if you have those specs for your on-prem solution, it's much easier to map them back to a vCore purchasing model, as Microsoft defines it. So this is a with Azure VM that we talked about earlier, those specs are like 1-to-1, right? Like those are a lot more kind of clear mapping to your on-prem. Over here, it's not exactly 1-to-1, but it gives you kind of more transparency versus the other model, which I'm going to talk about, which is the Dtu Purchasing Model. Okay, the Dtu Purchasing Model is a model that's really only applicable, as I stated here, with the Azure Sql Database. So this Dtu Purchasing Model, so as I said, the vCore Purchasing Model is for Azure Sql Database and Azure Sql Managed Instance. But the Dtu model, it's just applicable for Azure Sql Databases. And I understand the way they create DTUs, you don't get to pick your storage and your compute very clearly. What Microsoft does is they have a DTU unit, and it's really based on certain benchmarkings that they do. So Microsoft has a set of data, right? And they do certain computations on it. They'll have transaction types, maybe 35%, is read light, 20% is read medium, 5% is read heavy, update light, if you're making updates, is maybe 20%. Update heavy is 3%. Insert light is 3%. So they have like a mock or a representative of what they think an OLTP workload is, which is defined in here. And based on this workloads, they give you, they measure response times. So they're measuring response times that, hey, if we're doing this many reads and this many updates and this many inserts for this amount of data, are we able to get response time, under 2 seconds or whatever, the response time metrics that they have. And based on that, that's how DTUs work. The more DTUs you get, the more data it can perform this distribution of operations. So if your workload really maps to this distribution, then you really know what you're getting with the DTU. But if it varies, then you're not really sure what you're getting with the DTU, because so as we show here, the more DTUs you get, the compute and storage go up in a linear fashion based on those workloads that we defined in here, right? So if your workloads vary and you're thinking, hey, I'm going to get more DTUs, my performance is going to like double. That may not be exactly the case. So so because you don't have really visibility into the storage and the compute and being able to pick and choose like you do with the vCore model, and they're really making an assumptions based on kind of an OLTP data model, OLTP type of workload. This is not really like a recommended method of kind of picking your environment. And specifically for analytics workload, which they're not, the read and writes they vary, unless you have like we talked about, a replicated database of a kind of transactional system that you use for reporting, that you're going to be doing a lot of OLTP type transactions on it, right? For typical kind of OLAP workloads, this may not work as well. So that was kind of a little primer on the models of what a vCore based model is and what a DTU based model is. purchasing model is. So now we're going to get into what actual the Azure SQL Managed Instance is versus what an Azure SQL Database is. So with an Azure SQL Managed Instance, all you're getting are the databases, and you're not getting kind of the whole server or a VM around it. You're really purchasing a database service tier using that vCore model vCore base that we discussed. And within that, you have different tiers you can choose. They're general purpose or business critical. So if we look at our example, right, this is our kind of on-prem solution. You got a data mart, you got a staging area, and maybe a replicated transactional database that you use for reporting, and you got SSIS, SSAS, SSRS, SQL agent. You're really splitting that out into multiple databases into the cloud. You've got your staging is its own thing. This is its own database. A data mart's its own database, and what if you have a replicated database that that's being replicated from this on-prem system? You're going to have its own database, and the services that you're going to have to split out that you're not getting anymore is the SSIS. You're going to have to get additional kind of services for SSIS, which is going to be Data Factory. For SSRS, if you're running a lot of SSRS reports, you're going to have to do Power BI paginated reports for SSRS. If you've got SSAS cubes running, you're going to have to get SSAS cubes, in the cloud. You're not going to get that as part of this. So you're really splitting out your services. And what you're going to have to, in addition to the bandwidth cost here, to kind of move this, if your on-prem sources are still here, you're going to have the bandwidth cost of moving this out, which is there for pretty much all of them. But the key difference between the VMs, SQL Server on VM, and this option is that these services are now separate, right? So, but kind of the benefits though that you get with this option is really that the features of the database. Now we're talking about the specific features of the database. They're very similar to what you get on-prem. Pretty much you're getting the same features for if you have an enterprise license of SQL Server, the database features that you get, for on-prem database with an enterprise license server, they're the same features that you have here. Let's talk about kind of more details on that. Now, as far as the hardware is concerned, as I mentioned earlier, this gives you the Azure SQL Managed Instance gives you the vCore option. It only gives you the vCore option. With Azure SQL Managed Instance, there is no DTU option. And if you're trying to move to the cloud, I think this is like a very good option for you being able to have that transparency, because as you see here, when you are setting up an Azure environment in the cloud, you have the ability to pick your hardware. Okay, so as you're setting up a database, it asks you to pick a kind of hardware generation and hardware, and you've got your standard series, you got your premium series, you got memory optimized premium series, and based on those, you pick your number of cores, the memory per core, and the storage that you can reserve for that tier is kind of spelled out over here. So this if you're comparing from on-prem to the cloud, where you're not getting a full VM, you're getting a database. This gives you a lot of kind of backward kind of traceability. Hey, if I have a server that I'm using for my database server right now, if I use this kind of hardware generation series, what type of performance I can get, I can kind of come close to just comparing the hardware specs. You have that transparency here. So as I mentioned earlier, it's when you're picking your instance from if you're moving from on-prem to the cloud, as I mentioned, you're getting a database up here, but you've got different tiers that you can pick when you're trying to put a database in the cloud. So the two tiers that Microsoft offers for the Azure SQL Managed Instance, there's general purpose. They're kind of, as it kind of says here, they're kind of budget oriented, balanced, scalable, compute storage options. You use remote storage, whereas business criticals are, they have the highest resilience to failures, and they have several isolated replicas and provide the highest IO performance. So if you have databases that you have a needs for kind of high IO, this is something would be kind of a better fit. And once again, depending on what your existing environment is, based on the hardware that you kind of in the vCore model, you can select the hardware, you can get visibility into the IO you would get here as well. So as we mentioned, benefits, just to summarize the benefits of Azure SQL Managed Instance. The first benefit, it's basically a full-fledged SQL instance, and it has nearly 100% compatibility with on-prem. So if you have on-prem running, on-prem SQL Server instance running, that same instance you can kind of move up to the cloud, and you've got pretty much you've got the benefit of a SQL Server agent, profiler. You can do cross database transactions. So if you have a lot of scripts in a given instance, if you have multiple databases, right, and you're writing queries from one database to another, right, the database.schema.table name joined to another database.schema.table name. Those kind of database to database transactions are what I'm referring to when I say cross database transactions. They're supported here. They're not supported with the next option, which is Azure SQL Databases. So you can do user initiated and automated backups. You can have this injected in a customer VNet. And in the notes of this slide, I talk about a little bit more of these kind of features. These are not the only features. I just highlighted some of the features. In the notes of these slides, I talk in more detail about these features. And so with managed instance, like I said, this is if you're trying to move into the cloud and you just want a database to be closest thing to on-prem, this is a good option. So drawbacks, obviously, as we discussed, to summarize, you don't get the SSIS, SSAS, SSRS. You're just getting a SQL Server instance. You have less control compared to SQL Server, on Azure VM. This is not a drawback if it kind of aligns with the goal that you're looking for. You don't want to kind of do upgrades, because this is always matched to the most recent version of SQL Server. That may be a super benefit to you. There's certain options that we'll talk about later around kind of serverless, hyperscale are not there. Those are available with other tiers. So when to consider, these. If you need to reserve a kind of reserve compute and storage and have predictable and kind of transparent performance, this is a good fit for you. And as I said, it's best for migration, as it allows kind of existing customers to kind of lift and shift on-premise databases. If your environment doesn't exceed 16 terabyte of data from a storage perspective, this is a good fit for you, because with those service tiers, as we mentioned earlier, it does have a storage limit, and 16 terabyte, depending on your organization, it may or may not be a good fit for the application that you're running. From a replication standpoint, it can be push pull, distributor, publisher, and as we mentioned, if you want a virtual kind of network, while still taking advantage of having a platform as a service, fully managed database. So next option we're going to talk about is the Azure SQL Database. Now, the Azure SQL Database, it's basically similar to managed instance, except for, so for example, you have your on-prem server, that has your data mart, the staging environment, a replicated database, and SSRS, and SSAS, and SQL agent. Over here, you are splitting those up. And basically, the deployment option, you can do just a single database, right? So staging one database, data mart that you're running, that's another database, and your kind of replicated database for reporting is another database. You can run it as that, or you can run it as an elastic pool. The elastic pool, what that means is you can define your resources, right? So that we talk about the vCore model, you can define that the resources, your storage, your RAM, your IO at the elastic pool level. So this dotted line is going to be like your elastic pool that has all your resources. And these databases, you can set up their kind of minimum and maximum resources they can use, so that if your data mart needs more resources, it can pull more resources from the elastic pool. Or if your staging needs more resources, it can pull more resources from the elastic pool when it's using them. And it can kind of have the minimum defined resources available for the data mart. Similarly, for the replicated kind of database that you're running for a reporting environment, it can pull more resources as needed and use less as needed. It's less feature-rich compared with SQL managed instance, but it's still fully managed, right? So, and Microsoft really recommends it for kind of OLTP workloads, like SaaS applications that, and we'll kind of talk a little bit about that. There's some service tiers that they're introducing that are both for OLTP and kind of OLAP workloads, but generally Microsoft kind of recommends this for your OLTP workloads. Now, if you notice here, you don't have your SSIS. Obviously, you get the data factory, same as managed instance. So you got your kind of Power BI paginated reports, SSRS. These are all separate services now, same as managed instance. But also, you don't get SQL agent, right? So that's an instance kind of level feature that you have there. It's not a database, right? So that's not available. There's other ways to perform kind of scheduling operations and things that we typically use SQL agent for, but that's not there in Azure SQL Database. So, when we talk about migration effort, going from, on-prem into the cloud, then that's another thing. If you're heavily dependent on SQL agent, that's another thing you have to worry about, when you're moving into this option. So, that's something to kind of consider. So the purchase models here now, we talked about this earlier, you have the vCore option, and there's two tiers, serverless and hyperscale, that we'll talk about, that are options that are available just with Azure SQL DB. They're only available with the vCore model. So if the vCore model where you pick your storage and your compute and you have more control over it, using that, if you use that model, you can use something called a serverless or hyperscale, which we'll talk about next. Or you have the option to use the DTU model. This is a legacy model, and Microsoft is really starting to recommend more using the vCore model. The service tiers, you got general purpose and business critical, which were the same as managed instance, but they also offer these hyperscale and serverless with the vCore model. You cannot get hyperscale and serverless with the DTU model. So that's something to kind of keep into consideration. So when you talk about serverless, so with the Azure SQL Database, you get this option. All it is you define in a serverless model, for your vCore, you define a minimum and a maximum. Within that minimum and maximum, you're going to pay for at least this much as your loads are running. And then as your loads scale up, you'll keep going up and up until you hit the maximum. And that's what you'll be charged for. And then let's say you get to a point where you don't have any workloads, your kind of jobs stop. You can set something where you can just pause the database, and then you're not paying for anything. And then as your workloads pick up, it goes up. The hyperscale option, what this is you're basically, we talked about Azure Synapse in a kind of a previous talk, where now this is a brand new tier that they've introduced. And for me, this is really interesting because you can perform OLTP and OLAP, because you notice here, you've got your, it gives you multiple computes, and the computes are really separate. The storage is really separate from the compute, and the storage can go up to 100 terabytes. Whereas with the managed instance, it only went up to 16 terabytes. With using the hyperscale with the vCore model, you can go up to 100 terabytes. And with compute, you can have like a primary compute, which can do read-write operations, and you can have secondary like computes as well, which you can be read-only computes. So if you're doing OLAP workloads, this vCore-based hyperscale model for Azure Sql DB seems like a very interesting option. But once again, you don't have the SQL Server kind of agent option, right? Like if you're running the SQL Server agent right now, to move to this type of model to leverage these capabilities, you have to worry about all those other services that you're running on-prem to kind of split them out. So when to consider SQL DB? So you don't get the VNet that we talked about with managed instance. So if you don't need a virtual network, but you still want a fully managed, platform as a service database, not an instance, but a database, this is a good option for you. It is a high migration effort. For example, as you mentioned, the 3-part references of tables like database.schema.table. If you're running those all over the place in your existing scripts and stored procs and whatnot, that's going to be a lot of migration, because now you have to use the pools, right? There's a way to the databases within a Elastic pool can talk to each other, but you have to change your code. So you're going to definitely end up being higher migration effort. You don't want to reserve compute and storage. This might be a good option when we talk about the serverless option. If you have no clue, when your high peak loads are going to be, in that serverless option, it kind of turns on and off, pretty much on demand, or you don't have to worry about, kind of scaling up and scaling down that auto scale capability. This is a good option. If you have workloads that kind of fit that environment, this would be a good option. And obviously you can kind of, start and stop services. This is something which is not really possible with the managed instances. Kind of goes back into with the serverless option. If you stop it, you're really only paying for when your compute's not being used, you're really only paying for the storage. And as we said earlier, if you're fine with some of the features that you don't get, like SQL agent and some of the things that happen at the instance level, this might be a good option to consider. So last one that we're going to talk about is Azure Synapse Dedicated Pools. Now this option, it's an MPP cloud-based scale out version of a database. As we mentioned earlier, they rebranded Azure Synapse from Azure SQL Data Warehouse. And this is MPP really means, the scale out capabilities are just next level. The scaling out that you can do with Azure Synapse Dedicated Pools, it's really, you kind of the storage limits and the amount of data you can query is really, the 100 terabyte limit is just, it doesn't really apply. It's really, you talk about, hundreds of terabytes and the petabytes, you go there. Because the storage and the compute is just totally separated, and you can run up to 60 nodes, and we'll talk about a little bit of what that looks like and how the query performance happens. And the unit of purchase here, we had the vCore, we had the DTUs. The unit of purchase that you allocate to yourself and what you pay for is something called data warehouse units. That we'll talk about. Once again, it's a little abstract, like the DTU. You're not really picking hardware and kind of storage and compute or IO. It's a combined unit. So just like DTUs, if you add more DWUs, you get kind of linear performance, right? And instead of for DTUs, they use OLTP benchmarks. For this, they use kind of OLAP based benchmarks. We'll talk about in the next slide. Another thing from a storage perspective, the way the data is stored in this relational database, it's columnar storage. So your storage tends to be kind of more compressed and you pay less for storage in Azure SQL dedicated pools. But if you have an existing environment, on-prem environment with your data mart, staging and kind of replicated database, when you're moving those to the cloud, one dedicated pool gives you one database. So if I have 3 databases I'm moving, that means I'm purchasing really 3 dedicated SQL pools, and I pay for per pool. And that one pool, I'm going to set for that one pool, SQL dedicated pool, I'm going to pay for a bunch of data warehousing units. And another thing, when you're moving it out into the cloud, as you notice, I've got kind of partition A, partition B up there. You have to really to take advantage of the scale out architecture, because when you're running a query, it's going to throw that query on the multiple nodes to get the maximum performance, with this MPP architecture. To take advantage of that, you really need to have a partitioning strategy. The data needs to be partitioned as you move it up into the cloud. And similarly, the other kind of, drawbacks you were talking about with, SQL agent, having SSAS, having Power BI and Data Factory for SSIS. In Synapse, you get some of these features as far as the Data Factory, you get those, but they are kind of separate costs. So what you're paying for the data warehouse units and the databases, it's one thing. For those other features that you're migrating from on-prem, you got to pay separately. So talking more about data warehouse, how we talked about with DTUs, they had those kind of, read, write, and update and kind of updating and insert kind of benchmarks that they used to define what a DTU was. Over here, the way they define it, and you guys can kind of read them in more detail in the slide deck, but it's dependent more on how fast a dedicated pool can query a large number of rows and performs an aggregation, right? So it's an IO and CPU intensive operation, and that's kind of one factor that goes into how they calculate, DWUs. How fast can you ingest data, right? Because that's a normal kind of ETL operation that we use in a solution like Synapse dedicated pools. How fast you can kind of copy data into a table. And so DWU is really based on performing these operations on the left side there. That's what it's really designed for. And similar DTUs, as you linearly change DWUs, you get more performance, in line with that. So what are the benefits? As we talked earlier, it's really the storage and compute is totally separate. So that 100 terabyte limit that you have, you don't have with dedicated pools. You've got integration with big data and data in data lakes that you can merge with your kind of relational workloads. That's a big benefit that you get with having data in Synapse and dedicated pool. You can turn it on or off after processing, and you get low storage costs due to data being in columnar storage. As far as turning it on and off, we'll talk about that as well for drawbacks as well, because dedicated pools are very expensive. Based on the lowest number of lowest number of data warehouse unit kind of cost per hour is $1, and then the highest number you can do $4 per hour. Compared to, it's a few cents for Azure SQL Database and managed instances. So if you're going to keep it on at all times, this option is very expensive. The planning and migration effort is it's also great if you're moving kind of an on-prem workload into SQL dedicated pools, because you've got you have to have a partitioning strategy to kind of leverage the query processing engine, and it's really suitable for very large workloads. Only when if you don't have the data storage needs, and SQL database or managed instance can work for you, this may not be the solution for you. So only look at it when you've got the data volumes are there to take that you need to run kind of massive query operations on large kind of amounts of data to take leverage of this option. So with that, kind of end of the slide deck, and we'll kind of open it up to questions. Okay, I think